Thanks a lot, you all, for coming to this load testing crash course with Gatling. So let me introduce myself. I'm Stéphane Landelle, so I'm French, sorry for the accent, and I'm the creator of Gatling. I created something like 12 years ago, and for 7 years I've been the running CTO and co-founder of the company behind the project. So you can follow me on Twitter and find me on GitHub too. So with this talk, I wanted to help you understand what load testing is and how to properly define load testing tools, because over the course of years that we've helped people with load testing, we really feel like lots of people fall into some common pitfalls. So I really wanted to uncover those pitfalls in this talk. So first of all, quite often people don't run load tests. So I wanted to also give you an overview of why you should be running load tests, and also how to convince your boss that your organization should be running load tests. So the first step is we probably all have war stories from the trenches where we have run functional tests. The QA said that it was fine to ship in production, and then the application crashed in production. The reason for that is simple. It's because the conditions in QA environments are completely different from the conditions in productions. Not the same traffic, not the same amount of data in the database. And probably not the same size of architecture, not the same cluster size, for example. So it can be very hard to draw conclusions for just the QA environment and just functional tests on the QA environment. Those are probably not sufficient to guarantee that the application will work in production as expected, which is the ultimate goal. We don't want just the application to work in QA environment, but work in production for the customers and the real users. So why should you care about this? Well, it's because you might have a large audience. You might be planning also to have an increased growth, having to deal with more and more users in the upcoming months. You could also have some seasonal peak of traffics, like Black Friday, for example, if you're into e-commerce websites. So you might be also launching a new product. And if you don't care about performance, you might end up with a very poor user experience, so like crashes or even just slowdowns. And when this kind of bad things happen, you'll end up suffering money losses. People will start purchasing from your competitors. You will damage your brand. Or even if you're just running an intranet application, your intranet users won't be as productive as they should. Sometimes also a reaction that we see is that, oh, now we're in the cloud, so the cloud will magically take care of performance for us. We have auto-scaling configured, so everything should be fine. I'm sorry to say, but no, the cloud won't be fixing your performance issues for you. Even if auto-scaling does work for you, well, you'll be running way more cluster, possibly that you should be, so you'll be increasing your operation costs. And also you might end up just scaling out and adding more hardware. It means that you might end up running very large clusters, and those large clusters are way harder to operate properly. So if you can, try to focus on fixing your performance issues if it makes sense for you, and at least investigate them. So let's see what load testing is actually. So load testing is about trying to simulate artificial traffic against your target system. Either you want to reproduce typical production conditions, so the same kind of traffic, or you want to simulate special conditions, like I would say, I said before, for example, for Black Friday, you experience 10 times the nominal traffic for the rest of the year, for example. And so you will be executing what's called virtual users that will go through scenarios. And then what you want to do is, with this kind of test, you want to define acceptance criteria and validate that your application actually meets those performance requirements. So for doing so, you'll be analyzing the response times. You'll be also analyzing what happens on the server side during the load test to figure out where the performance issues actually are so that you can fix them. And it also help you properly size your infrastructure. Do you need more load balancers? Do you need more servers in your clusters? Do you need to upgrade the database, etc.? What load testing is not. So first, it's not about web performance. It's not about checking the performance of what happens in the browser, how fast your JavaScript draws, paints and does the rendering in your web browser. Those are different sets of tools and different sets of tests. And also, it's not about running headless browsers at scale. Don't think about running thousands of Selenium concurrently. This wouldn't really work. The thing here is that headless web browsers use lots of memory and CPU. So you cannot run more than 10 or 20 headless web browsers from a single machine without actually hurting performance. So if you need to generate thousands of users, you need a large fleet of machines. So now really about the pitfalls about load testing. So, because everything usually starts from a requirement for business. For example, the application must be able to withstand 1,000 users for 1 hour. And it can be very hard to figure out what kind of test to implement from that and what sense make from these requirements. So let's dig into this. So in order to build realistic load tests, the first thing you need to know is figure out how your application actually works. For example, is your application stateless or stateful? If it's stateless, it means that most of your requests or all your requests are GET or HEAD requests, and they don't modify the state of your application. Typically, they don't modify the state of the database. In this case, traffic is typically anonymous, and typically we're talking about content websites like news. In this case, load tests are pretty easy to build actually. Because all the requests can be executed in any order. It doesn't matter, so you can mix them all together, and this way you can also easily replay traffic. So typically for this kind of test, you could use an access log from your HTTP servers, and then just define this as crawl the list of all the different URLs and replay them. Just define the number of users you want to use to go through this list of URLs. This is how you would do with Gatling. So define what's called a feeder. We'll go back to that a bit later, and then execute this request coming from with the URL coming from the feeder file. If your application is stateful, things are a bit more complicated. Your request will involve post and put requests, and so it means that they will modify the state on the server, and then also it typically means that your virtual users will have to implement logical flows. For example, if we're talking about an e-commerce website, you cannot have a user flush the cart and purchase if he hasn't put items in the cart in the first place. So there's this kind of sequential logic in your flows. And that's where you need to implement scenarios. So here, for example, in Gatling, you would do first execute the request to do a login, then execute a request to browse the catalog, then do a request to add an item in the cart, and then another request to purchase. And that's sometimes where people start struggling because they don't know where to start. They don't have any load tests yet. They don't know where to start. Should I be trying to cover all the use cases in my applications, all the features? Where do I start? So my advice here would be really to focus on your most critical features and really start from that. It's better, honestly, it's better to start with something that starts with nothing than do nothing. You could still be missing some important pieces, like a very rare flow in your application that just takes down the whole application, for example, triggering some use case that just pumps all the data from the database, and all the other users will suffer from the high usage peak on the database. But still, you'll iterate and you'll improve from that. And if you've never run any load test before, just focusing on your most critical features will most likely help you uncover performance issues. The second thing is to be also familiar with your infrastructure and your network. What I mean here is that, so typically your users, well, testers or typically developers are really just focused on the bricks of your applications that they are the most familiar with. So typically focus on the code, typically focus on the database that their own code is using. And when those testers are really just focused on those pieces, they might be missing the other pieces of your application that are actually pretty critical, the infrastructure, the load balancers, the servers, etc. And so typically, testers tend to not be super familiar with those bricks, in particular network and network usage. Because all the requests and responses going between your actual users and your target application that runs the code needs to go through the network, of course. So typically, when your users, so actually the user agents, let's talk about user agents. That means the program that's actually triggered the request. So those can be a server, or those can be a web browser, or those can be mobile apps, for example. So first, the user agent will have to connect to, first the user agent will have to figure out where your servers are actually located. It will have to resolve your host name to figure out the IP address. So, and this involves some round trips, going to those DNS servers to figure out the proper address. In most cases, this can be not an issue for you, typically if you don't run your own DNS servers. But sometimes you do run your own DNS servers. For example, if you want to load test intranet applications, so not relying on internet DNS servers, or if you're running your DNS server to handle very large loads. For example, if you're running a Route 53 server on AWS, that would do round robin for your multiple load balancers. So in this case, it might be interesting for you to check the performance of your DNS server. Then the second thing is, okay, now your user agent knows the address of your target servers, possibly multiple ones. Then the next step would be to open a TCP connection. So this is the next round trip, trying to open a TCP socket. And then there's a good chance that your traffic is not clear HTTP but actually HTTPS. So it means additional round trips and additional work for performing the TLS handshake and creating TLS SSL sessions on the server and the client. So you need to figure out how in your test what the actual user agents are, so that you can figure out the connection usage of those user agents. Typically in your tests, if your test is about simulating public-facing traffic, you want to test your whole application and really have the end-to-end performance from the real users, the kind of real user agents. There's a good chance in this test that you want to simulate tons of web browsers. And in this kind of test, it means that all those different user agents will open their own connections, perform their own TLS handshakes, create their own TLS sessions, and this is a huge burden for the public-facing traffic on your side, facing server on your side, typically your load balancers. And in this case, the number of connections and the number of TLS handshakes can be bottlenecks. And this is where you might see connection timeouts and TLS handshake timeouts. And you can also you can only see these kind of failures if you run load tests or if you do some monitoring on the user agents directly in the browser. That's not something that you can see on the monitoring on the server side, because the issue is really between the user agents and your public endpoints. This is the default behavior in Gatling. In Gatling, by default, we try to simulate large fleets of web browsers. So every virtual user has its own connection pool and does its own TLS handshakes and TCP connections opening. Instead, if what you want to simulate, to test is actually, let's say, a microservice that lives behind in your own private network, and that the user agents for this service is actually another server, like another microservice, or your load balancers. Okay, you want to test a microservice in isolation. In this case, the user agent is way likely to have one single shared connection pool, and it will just open a few connections and perform it. Maybe it's just clear HTTP, so no TLS handshake, and keep those connections alive. So in this case, let's say the network impact of is way smaller than in the first case. In Gatling, you would need to enable share connections to have this kind of behavior. Use it properly. Just like any settings, you need to use the setting that matches the actual behavior of your target system. Don't try to use to kind of trick the system and enable this setting while you actually want to test the first case, because okay, you will have way better response times, because way less handshake and way less burden on the server to handle the TCP and the TLS, but your test won't be realistic. Next step is about picking the proper system model for your system. So the words open and closed workload model, system model, come from the queue theory. So this is what it's about. An open system model is where new jobs arrive independently of job completions. New jobs keep on being started over time, whatever the number of running jobs at this time. This is valid not only for load testing, but for any kind of system. It can be a bank, it can be an application, whatever. In this kind of situation applied to the scope of load testing, it means that the virtual users keep on arriving, whatever the number of concurrent users already connected to your application doing some requests against it. When in this kind of situation, when the response time starts increasing because your system starts suffering, the virtual users will start, the concurrent users will start piling up in the system. And you will end up with a crash because you just have too many users and trying to deal with too many requests. Again, this is how you would do with Gatling. So you would inject an open, use inject open to here create 100 new virtual users every second for 1 hour. The opposite system is a closed workload model. So in this case, new jobs can only be started when you are at full capacity, when other jobs complete, because you have a maximum capacity. And all the extra jobs that cannot be started are being pushed into a queue. So in the scope of load testing, here it means that you have a capped number of concurrent users. And if your response time starts increasing, in order to avoid to increase the number of concurrent users, the tool will stop injecting new users, and will wait for users to complete their scenario to start new ones. Again, this is how you would do with Gatling, how you would here have a constant number of 100 users during 1 hour. So meaning that you will start 100 user, have them complete their journey, and every time that one completes the scenario, start a new one. All this for 1 hour. So what's super important here is really to pick the model for your test that matches how your application works. Does your application have this kind of queue in front of it that would introduce a maximum capacity and push the extra users into this queue, possibly displaying them in a splash screen? Your estimated waiting time is 10 minutes, for example. This is the kind of systems we typically see in gaming platforms or in ticketing platforms. Those systems do have a maximum capacity. In France, we also saw that for the vaccination campaigns. Most systems don't have this kind of queue in front of it. They haven't implemented these kind of things. So you really must not use a closed workload model just because, let's say you have a wrong requirements because people who express the requirements are familiar with concurrent users coming from, let's say, Google Analytics, and that your system is actually an open model. Okay, because you're going once again, compare apple and oranges, create some tests that don't match the behavior of your actual system, and really you won't be able to draw any conclusions on how your system will fare in production from your actual test, because they won't match. Now we've talked about injection profiles. Let's talk also about the different load test types that you can create. So a typical load test would be the capacity test. In the capacity test, you increase progressively the load, possibly with ramps and plateaus. So you want to figure out how your application scales, and at which kind of load your application starts experiencing failures or poor response times. So you know your maximum capacity, in short. The second quite common test is stress test. There's often a confusion between load test, and stress test. Stress test is a specific type of load test. A stress test is about simulating a rush of traffic against your application. And with this test, you want to figure out how your application behaves during this sudden rush. Does it just crash? Can it still serve a few users, or can it serve no users at all? And also how the application behaves after the peak. Can it progressively go back? Can your application progressively go back to a steady state, or is just your application completely broken and you need to reboot the servers, you need to reboot the database, you need to purge some caches, and basically you're losing data. The next type is soak test. So with soak test, you'll be running a steady load for a long time. And with this kind of test, you want to detect typically leaks, resource leaks, like memory leaks or file descriptor leaks. These kind of leaks that you cannot detect if you just run tests for 1 hour, but only on a long time. And finally, the last kind of test, it's not a real load test, but it's a kind of test we actually do a lot. It's called smoke test. It's making sure that your test actually works properly with just one single user. This kind of test is actually super important, because you really want to run the test periodically to make sure that the test keep on working as expected. Typically, when you change your application, you modify your application. Next pitfall, test data. Your application has caches everywhere. In the database, in the just-in-time compiler, possibly you're also using some Java library to implement some application caches, like Caffeine. You could also have cache applications like Varnish. So in this kind of situation, if you have this kind of caches, you want to use your caches the same way they are being used in production. If all your virtual users use the same data, the same record, you will use your caches in a super nice way. You will have super fast response times, but this won't be the realistic conditions where the caches are populated in a different way in production. So what you really want to do is what I showed you before with a CSV file. Remember the feeder. You avoid static values for the data, and make sure to inject test data into your virtual users to have them spread over multiple test records. Next step is about how to measure performance. Things start to getting a bit better about this, but for a very long time, people have only considered as an interesting metric the average response time. This is just super bad. The average response time is just kind of useless metric. I mean, if you have a bad average value, yes, you have poor response time. But if you have a good average value, you're probably missing a good piece of the picture. On this chart, you can see that we have a long tail after the average value. This long tail can be just outliers, fine, but they could be very interesting values. Could be that actually 30% of your traffic is actually way below. This is something that you want to figure out. You cannot just trust the average value to guarantee that you're fine, and that most of your users are fine. Another case is that your distribution could be what's called multimodal, several modes, several peaks. Okay, and in this case, you can see on this chart that the average value is below the second peak and below than the median. So actually, there are lots of users who experience way way worse response time than the average value. So in short, don't use averages on your percentiles, or on your response time, sorry. Sometimes we see some people kind of completing the average value with another metric, that's the standard deviation. This is also a bad idea, sorry to say. The standard deviation is supposed to represent how far your values are from the average value. Actually, it only makes sense in maths for normal distributions, not the kind of distributions I showed there. So you can see in this animation, all those different data sets have the same average and value and the same standard deviation and completely different shapes. So that's not a metric that you can trust. One set of good metrics are percentiles. So percentiles, maybe some of you are familiar with it, I hope so. Percentiles are thresholds. The 50th percentile, which is also called the median value, is the value that's above 50% of your values. The 90th percentile is the value that's above 90% of your value. The 100th percentile is the maximum. Those metrics are pretty nice to define acceptance criteria. Like I want in 90% of my other cases, I want my response time to be below 2 seconds. And in 99% of the time, I can accept that they go up to 5 seconds, for example. One important thing with percentiles is that you cannot compute averages on percentiles. It doesn't make any sense from the maths point of view, just wrong. If you want to be convinced about this, the 100th percentile is the maximum. If you measure the maximum every second, and you want the overall maximum on a given time window, are you going to compute the average of the local maximums? No, it doesn't work. You want the maximum of the maximums. And if you compute the average of percentiles, you're going to smoothen all your hiccups, because your distributions are typically not stable over time. And you want to detect those temporary hiccups. So just don't do that. And sadly, honestly, lots of tools do that. AWS CloudFront does that, and lots of other tools. Lots of tools are not properly built to deal with distributions and properly compute percentiles. Once you have stored percentiles in the database, you cannot recompute anything from that. You can just do broken maths with average percentiles. You need to store distributions. So you need a tool that can store distributions. So don't assume anything about your distribution. That's really what you want to figure out. If you're actually losing 10% of your traffic because those 10% of users have experienced poor response time, and because of that, they are going to purchase somewhere else. And measure them properly. Check how both your load testing tool but also your monitoring tool actually reports you percentiles. Don't just trust the data that they give you blindly. Know the possible limitations of the tool you use. Check the documentation. And those percentiles can be super useful to define acceptance criteria. Business people can easily understand what percentiles are and how they can help them define acceptance criteria. Next step, when should you integrate your load test in the development life cycle? My advice, at least. Historically, people tended to run load tests really super late during the development life cycle, typically just once or twice a year when they've completed developments. And in this kind of situation, typically this kind of test was arrived very too late, was super bringer of bad news. Like we need to reconsider some architecture choices. We need to reconsider some development choices. And in this kind of situation, it's typically too late to fix. So typically, you need to reconsider your go live. Nowadays, you're supposed to integrate tests in your continuous integration pipeline, because the value of tests is to bring quick feedback, so that you don't have to dig into 6 months of Git history to figure out which commit introduced the regression. You want to quickly fix things when things are still fresh in your mind. Who should be running load tests? Historically, load tests were the kind of were only handled by a few experts on some tools quite often, and those people acted as a kind of central team for the whole organization. And honestly, in my opinion, it didn't work. Those central teams ended up being bottleneck for all the different project teams, and it was kind of hard to collaborate on because every time they needed to work on a project on a given application, they were not familiar with the application and not familiar with the changes that happened for the last 6 months. So nowadays, if possible, you really should collaborate on try to get the load tests just like the other tests inside your product teams. You might still need some performance experts, but have them work on helping you with uncovering and fixing the performance issues instead of just maintaining and crafting tests. Their values should not be there. And then we're coming to tooling, and so you need some provisioning tools so that you can to run load tests because you need to probably spawn a target environment. You also probably need to spawn machines that you will generate load from. You don't want to run a load test from your local laptop. You don't want to run it from a CI node that's running also some other processes at the same time because the load test process will compete for resources, CPU, memory, with other processes on the same machine. The good thing here is that nowadays we have the tools to do that more efficiently than we had 20 years ago. Then you'll need also some monitoring because load testing is not just about knowing that you experience of performance issues, but you want to fix them. So you need to need tools to investigate what happens in your target system so that you can fix the performance issues. And finally, you need some load generator, load testing tool, injectors, several words for that. And that's where Gatling shines. So a few words about Gatling and the different solutions in our company. So Gatling has an open core model, meaning that there's an open source software, and we've built an enterprise solution on top of that. So the core open source software is under Apache 2 license. You can fetch it on GitHub and check the sources there. The approach that you want with Gatling was, instead of historical tools that are graphical user interface oriented, we only wanted to have something code oriented. The reason for that, it's really an opinion, but the reason for that is that we strongly believe that GUI tools are very hard to collaborate on. While if you have code, it's way easier to maintain, it's way easier to push some test code into Git, to do some pull requests, so that your peers can review the test code. You can organize the way you want, and also that the large force of the product teams, which are the developers, will be able to use this kind of tool. So Gatling runs on a JVM, so it provides you with a Java API and a Scala API. You can also use it from Kotlin. It integrates nicely with the Java world build tools, typically Maven or Gradle, and as it's just code, you can easily store it into your Git repository and tag it and do pull request and attach it to a version of your of the sources of your application, for example. It supports lots of different protocols, both officially supported protocols and also some protocols supported by the community. So a kind of large set of supported protocols. Let me show you what it actually looks like. Isn't displaying anything? Maybe it restarts? No, sorry. Yeah, whatever. Oh. So here you can see, I hope you can see in the back, but it's a very standard Maven project. In order to use Gatling with Maven or Gradle, you just need to add the dependencies in your build file, and the build tool will download the dependencies from Maven Central. We also distribute Gatling as a standalone bundle, so with different folders containing the libraries and the load scripts, etc. So you don't you don't need to use a build tool and an ID like I'm doing here if you don't want to. You can just run from the command line and use a text editor. So in this sample, it's already a bit rich. This is the final results of the tutorials we have on our website. So if you go on in our documentation and go through our tutorials, this is the result you'll come up with eventually. So it's really just a Java class. You need to import add some imports to use the Gatling API. You need to create a class that needs to extend simulation so that this is the entry points that the Gatling engine can discover and launch. But then you can really extract the code the way you want, and then recombine it the way you want. You can build libraries with Gatling. So here, for example, we are creating a feeder file. Again, a data source that all your virtual users will be using to pick data from, so that they play different data, not just one single record. So this is a CSV file that would be over here. Yeah, just plain old CSV file with 2 different columns and 2 records here. And here, so we've split our whole scenario into different smaller pieces. This first piece is about a search process. So you can see that virtual users will first go to the root of the domain, then do a pause of 1 second, grab a record from our CSV or a random record from our CSV file. So actually what happens here is that we'll copy the record and add new attributes in the attribute maps of the virtual user. And then generate a request. So you can see that it's an HTTP request, it's a GET one. The path here is dynamic. You can see with these sharp and curly braces, it's one way to build dynamic requests with Gatling. This pattern will be replaced dynamically on each execution by the value matching the record that we added previously in the database. Here, search criterion and search criterion is the first column. And once we receive this response, the response of this request, we're going to apply a check on this response. Validate that the response was the one we expected. So here using, as the test is testing an application that has server-side HTML rendering, where we are passing the HTML with a CSS selector, with a dynamic query again, and we want to capture an href attribute to save the link that we want to crawl. Basically, we are searching some products, and we want to select a specific product so that we can go to the product details page, which is what we do here. Okay. So this way, so the Gatling DSL is pretty rich. You can have also loops. You can have conditional blocks. You can have switches, like you want 90% of your users to do this, to go in this path, and the rest of the traffic going this other path. You can have retry. So the DSL is pretty rich. And in your test, what you end up actually doing, so here we've created some pieces of scenarios, but we want them to build actual scenarios. And we're creating them by composing and chaining our small pieces. So we here have 2 different scenarios. Regular users that will do search and then browse, and administrators that will do search and browse and then edit. Okay, so, and then in the setup, we're saying this test is about starting those 2 different scenarios concurrently here with 2 different injection profiles. We don't have the same amount of users and administrators. So you can have multiple scenarios in the same test, possibly running them concurrently or sequentially. You have different options. So you can really build very simple tests or very complex ones, and benefit from that is code, really do composition and create some constants so that you can reuse them the way you want. Once the test is done, Gatling will generate some reports for that. Sorry. That would look like this. So basically it has, oops, sorry, wrong. You would have a first global page. don't know if everyone can see in the back, a global page with the list of all the different requests in the test and aggregated stats for all the different request types. So for example, here you would have the overall response time distribution. But then, for example, in this table, if you can look for the request with the worst response time, the worst P99, and select it and go back to the charts and the stats for filtered on this specific request type, so you can have more in-depth details. So this is mostly what you have with the open source version of Gatling. You also have a component named the recorder that you can use to record traffic from navigation, the traffic generated by your navigation from a web browser, for example, so that you can start. It can give you a nice way to bootstrap a test. In particular, if you're not familiar with the API calls generated by the client-side application. And then you can also might be interested in using the enterprise version. The enterprise version provides you with a controller to administrate all the tests for your organization. So there you would define, you would configure the test in the platform and possibly configure where you want to deploy your load generators. So for multiple locations from all over the world. You can also generate load if you use the self-hosted version and not the cloud version from your own private network. This is particularly interesting if you want to test applications that are not exposed on the internet. So, we're currently working on a hybrid mode so that you can bring your own injectors for the cloud, for Gatling Cloud. And this way you can have way more metrics than what you have with the open source version. Let's maybe go with this one. Lots of failures, but lots of stats. And here you have a live dashboard. You don't have to wait for the end of the test to have the feedback. So you have all the request stats, so the throughput, the requests and responses per second. You have the response time distribution over time, the errors. You can zoom in and zoom out on a given time window. We properly compute percentiles and distribution and recompute them and aggregate them properly, like what I explained before regarding computing averages of percentiles. We don't do that. Yeah, also, of course, you have a summary of all the different request types in the test. And you have more metrics. So here, typically, you have all the connection metrics. So you can figure out if you have some issues with TCP or with TLS. And this way you can so you can trigger the test manually and directly from the web interface, but you can also use our REST API, and we also provide integrations with other tools like CI solutions, like Jenkins, Bamboo, TeamCity, whatever actually a CI solution. Also provide a data source for Grafana if you want to consolidate data coming from the Gatling injectors and from the monitoring on the system and the load. So you can figure out if, okay, I have very long response time and this is caused by this given issue on the server side. And that's basically it. Do you have some questions maybe? I don't know if there's somebody with a microphone. No? So just so that you know, so if you want to, so this is a kind of vendor talk. So honestly, make your own opinion about the tool. This is something I strongly recommend. Run your own benchmarks. This is valid for any solution. Go check yourself the documentation, run your own tests. If you have some questions, we also have a community forum that you can reach, where you can reach out for help. Also maybe Stack Overflow. We have some online training if you want to learn more about Gatling, and those online trainings are free. So you can try it yourself. You want to try the enterprise version, there's also free trials. If you have some questions, we have a booth over there, booth 26, so really feel free to come over. And that's it. Thanks a lot.